Let's see what I can do. All right. Push this button here. We'll push that button there. Five, four, three, two, mark. Yep. It's that time. Live from the Crescent Moon Temple, it's the morning show with your host, Tolinar. It's time to play the music, switch all of the cameras on. It's time for the morning show, and I'm not quite on my own. We have an audience member. Let's quickly check the chat room. Everybody out there, give a nice holler. Here we are. It's time for the morning show, and we're having some fun, kind of. Thank you, stage light. The host, the guest, the audience, it's what I'm meant to be. There's nobody else out there, except for that one guy, Newbie. And that's nothing unusual, it's just another day. I'm sure I can get through it all if I do it my own way. Double check Twitch integration. All systems good to go. One last quick mic inspection. We're okay for audio for now. Pick a topic of conversation. Something I ought to know. Modern news is too confusing. I'd rather talk about math as an invention. That's much less complicated than politics. Let's talk about that today. The host, the guest, the audience, it's what I've got to be. There's almost no one out there, but there is one guy, I guess. And that's nothing unusual, except for that one guy. Woohoo! And if I want to get through this stuff, I'll have to do it my own way. The host, the guest, the audience, it's what I've got to be. I'm really still quite sick, but this all depends on me. So I'll keep chugging Gatorade just like yesterday. I'm sure I can get through it all, but I'm probably gonna sneeze into the mic a bunch today. Today on the morning show, we will discuss the fact that math is not a natural law, but instead a human invention. What the hell? Also, the cat is going to make noise. It's got that look in its eye. I know it's coming. Okay. Today's morning show is brought to you by the letter N and the number 1. And by viewers like Newbie, my most consistent viewer. We're going to jump straight into it today. That's right. Today is Thursday, February 26th. The one. Today we will be discussing math as an invention. It's a good question. Is math finite or infinite? We will get into that very same question. That's where we're going. That's where we're going today. What is the true nature of math? What is the answer? Okay, we're also going to get some tea because I am still sick. There we go. Eventually, I'll work out a better system for this blackboarding concept, but for now, this is doing okay. a little loud, as usual. So let's start some tea. And why don't we just jump straight in? Mathematics. What is math? What is, now many people will claim that mathematics is integral to the universe, is present everywhere you look. But this is not so. That's not to say there aren't rules in place in the universe. There are. Most definitely rules in place. The world is strung together by a fundamental set of rules. But this set of rules is different from mathematics. For example, the idea that the universe divides up into a base 10 system is entirely human invented. The decimal system is Arabic, and then earlier than that, probably Mesopotamian in nature. We chose 10 because 10 is the number of fingers we have, making it easy to organize concepts like 10, 20, or 30 by using your fingers. If we had a different number of fingers, we probably wouldn't choose a base 10 mathematical system. And the numbers would be very different than they appear now. The strange repetitions that we discover in mathematics in its current incarnation actually appear in other systems too. For example, in a base 7 system, 7 has the same systems of recursion and number repetition that appear in base 10 systems around 10. In a base 8 system, which is perhaps more elegant than a base 10 system, 8 and 4 repeat all over the place. But we are all used to base 10 mathematics, so it appears perfect. Math, however, as I've mentioned, is a human invention. We invented math. And why did we invent math? To make the universe easier to understand. Consider, for example, counting. It's very easy to tell if you have 3 oranges, okay? But what if one of those oranges is rotted? Well, you technically have 3, but only 2 are worthwhile. Or you could quantify the oranges in pounds, but that doesn't describe how much fruit you get without the skin. Maybe one orange has a lot more skin than the others. You see, math is a way of estimating reality, but reality by its nature is full of exceptions. Math just happens to be the most convenient tool for estimating. Math is infinite, but only as infinite as human creativity. Where we choose to apply math and how we choose to apply math determines the finite boundaries of math. You can only use math to quantify something that exists. However, math has a parallel. The world is bound by certain rules. Rules of fractal patterns, rules of specifics. This can be considered by a number of different names. My favorite name for it, though, is the holy geometry. There are shapes that occur naturally in life, patterns that recur in nature. The world very succinctly knows about these patterns, the rules that very silently govern reality. Everything follows them. You do too, whether you know it or not. And the world follows these patterns and sequences very, very closely. It's not that the world does have no structure. It's just the structure is not congruent to math at all. There are places where math does what it wants to do, such as the number 0. 0 is a very useful tool invented by the Mayans. However, 0 is not an actual thing in reality. It is the absence of reality, the first imaginary number. because you see 0 represents the absence as opposed to the presence. Now, logically, 0 is functional because you need to think about the absence in order to be good at estimating. However, absence is lack of presence, which means all of the rules that we've ever applied to 0, the fact that multiplying things by 0 gets you another 0, all the mathematical things you can do with a 0, they don't work in real life. Instead, 0 represents absence. And that means the absence of reality as well. So wherever a 0 appears in reality, you end up with an absence. You're like, well, what about the tens place? Well, that's the base 10 system again. 0 changes its location depending on which base you have. So it's virtualized. 20 doesn't contain any zeros. 20 doesn't contain a single 0. That's right. The speed of light is a perfect example. The speed of light is a number based on, oh, I'm getting bugged by some guy. Just a second. Flop. Okay. So, the speed of light is a number based on speed, which is cool. Let me see if I remember what that number is. It's somewhere around 300 million meters per second. Very close. This is the speed of light through a vacuum, assuming there's nothing in its way, right? Most people know 186,000 miles per second, but 300 million meters per second can be seen as the speed of light. But we have discovered this isn't the fastest speed in the world. Fully understanding something like this is beyond the average person's understanding. It's not that the rules don't exist, it's that we don't have a full comprehension of the rules. A good example is the speed of sound. The speed of sound is roughly 1/1,000,000th the speed of light. The speed of light, let me get my notepad here. "300 million meters per second." Right? Speed of sound, 300 meters a second. So, it is literal that the speed of light is 1,000,000 times faster, almost 1,000,000 times faster than the speed of sound. Why does sound move at this speed? It's the speed that a shock wave moves through the atmosphere and Earth. All of our calculations are based on Earth. And it turns out if you change the nature of what sound is passing through, you change its speed. The speed of light is the speed that a different energy wave moves through the atmosphere, through vacuum, and then it slows down as it runs into air. What's really impressive is that as things try to move faster than their base speed per second, they take on extra mass because of everything else they're pushing through. This is why Einstein theorized that as you got closer to the speed of light, the mass continues to increase in a cumulative fashion until the speed is no longer maintainable. He saw the speed of light as an unreachable quantification. But now quantum mechanics is there to throw the whole thing into an uproar. Quantum mechanics work faster than the speed of light. All of these delicate rules throw math into question. Even the number 300 million meters per second is not correct. It's inaccurate. More than inaccurate, it does a bad job of measuring because it's impossible to grok. 300 meters per second. That's something that you can think about. Let me see here. In terms of miles per hour, the speed of sound is 767 miles an hour. In other words, if you go 800 miles an hour, you go faster than sound. You think, well, that's never going to happen until you get into a fighter jet. Fighter jets can go faster than 770 miles per hour. And the moment they do, they breach the sound barrier. A supersonic plane produces a sonic boom. Different than the incredible tear that we hear as the rockets from a jet plane tear through the sky, which that produces a lot of noise as well. The sonic boom from going supersonic has a distinctly loud and powerful effect. Now, we have become used to these things because they happen in reality. But for someone who has never encountered them, they are terrifying. That's what happens when you start busting up the natural rules of our environment. Perhaps the simplest example that can be given of a mathematics not doing is probably this. Let's see if I can get a hold of this little symbol here. Right. Let's talk very briefly about pi. Pi is a number. It's a number very slightly higher than 3. What is the importance of pi? Well, there's a long series of digits you can memorize and rattle out. 3.1415, big deal. Who gives a shit, right? Here's the truth of pi. Pi is the multiplier for taking a string and stretching it into a circle. You need 3 times more string to turn a line into a circle. A circle with the same size as the line. So we take a circle of length of 5 inches, just a string of 5 inches, and in order to turn that into a circle, we've got to have about 3.14 times more circles. We need about 15, 16 amounts, 17 amounts should be enough, and then you'll be able to create a circle that is about the same width as that line. And this number that we use all the time, called pi, is very well known to nature. It appears everywhere in nature. Nature abuses pi and uses it. Every single living structure uses pi. It shows up and shows up and shows up. Pi is very frequent in natural geometry. It shows up in the fractal construction of the world. Every circle that's ever created obeys it. It is something that nature has no problem expressing. It just appears. Pi. Sure, there it is again. It follows the rules exactly. Because if you take a membrane of this length and fill it with as much as you can without it bursting, you end up with a circle. And the circle's going to have a circumference equal to the diameter times 3.14. And if you turn it into a sphere, now you need to square it. Multiply it by itself. It's a circle times a circle. Make sense? Imagine taking a ring and spinning it. You're generating a circle of circles. Circle times circle equals sphere. Cool, right? It's so simple and elegant. Nature loves elegance, although sometimes it gets wild. Here's the thing. Pi is a number, but we use a special symbol to represent pi. Why do we use that symbol? Because representing pi as a number is hard. Pi doesn't like to be held in a number. Pi is a piece of holy geometry, not a number. So it doesn't behave the way numbers behave. It's not discrete. If you try to write down all the digits to pi, it never ends. And it doesn't repeat itself either, like all numbers do. It is a non-terminating, non-repeating exact figure. And we know it exists because it appears in nature everywhere. It just doesn't play the same way that ordinary numbers play, because it is not a number. Pi is not a human invention. It is a piece of holy geometry. And we can express it in our math the same way we can express everything in reality as math. But it is not mathematics. Pi is not human math. Pi is natural existence. Pi is holy geometry. Pi is here without the math. Pi comes before the math and after the math. So why do we even bother? What is math good for? What's the point? Well, the point is that math is really, really, really useful. Math is handy. Math makes it easier to solve our problems. All our problems. If math wasn't such an effective tool, we would have abandoned it long ago. But as it turns out, math is one of humanity's strongest tools, perhaps even stronger than the chisel, although it's close. The chisel is a very useful tool, but mathematics might be stronger than a chisel. The only thing I can guarantee is stronger than math is language. Language is another human tool that is more powerful than math. All the languages used on the planet Earth are stronger than mathematics. More useful, more effective. Now, when it comes to comparing tools, there's a limit. A hammer is always a hammer. And there will always be a need for a hammer on some level. In this same way, mathematics makes it easy to estimate reality. And that's what that tool does. But while mathematics makes it easy to estimate reality, language allows us to describe reality. It's quantity versus quality again. Math lets us quantify the world, helping us keep careful track, helping us understand and solve problems. And it will always be imprecise, despite its attempt at precision. Math is only an estimation. Math can never be exact because of, like I mentioned, the fruit rule. 3 oranges in mathematics makes easy sense. 3 oranges in reality is not a precise amount. You don't know how much you're really getting here. Maybe one of them is a mandarin. Go for it, kitty. I opened the window for you. So it goes. Math is an incredibly interesting tool and system for evaluating on quantity. And language is for describing the world. Aggregate based on quality. Math is something of a language, but it's not limited just to physicists. Math is a way of communicating about the quantity of the world in the same way that language is a way of communicating about the quality. Many cultures that have different languages use the same mathematics. Now, there are other languages designed to express, that's loud. There are other cultures designed to express other languages designed to express the nature of the world around us, designed to express its qualities, to talk about all of the different things. But math is all about calculation. And it's inaccurate. And it's okay that it's inaccurate. Math is not about being precise, although it strives to be precise. It's about providing the best possible guess. It's about getting as close as you can get, not being exact. That's what math is good for. Now, you tell this to a rocket scientist, they're like, no, math must be exact or it's useless to me. Which is fair. That's fair, you know. When you're working with such a delicate thing, you need to be as exact as you can be. And math is your single operant. It's the one thing you must have. Above all else, you must have the math. But there are limits to this. This is a person who has spent their life seeking precision. A person who spent years and years chasing accuracy. The average person will not use math in this way. The average person will use math to solve their problems by making generalizations, estimates. And even then, sometimes those rocket boys get too big for their britches and then their rockets go boom, boom, bye-bye. Because perfection is hard for people. But being good enough, we can do that. We're good at being good enough. Math is an invaluable tool in humanity's tool belt. But it is only a tool. We invented it. Now, its look-alike, the holy geometry, that's no invention of ours. The fact that when you strum a string, you get the note, and then cut the string in half, you get the same note. Make a string 2 times its length, you get the same note. That's harmonics, and it's a part of holy geometry, not math. The fact that triangles are so strong as to be nearly indestructible compared to the square which just falls over, that's holy geometry, that's mathematics. All of these different interaction systems, from the transference of energy through the physical rules of the universe, to the co-adaptation of heat. The universe is bound by a set of rules similar to math that can be learned and known. But these rules do not operate under the same rigidity that math does. Math has end and begin points that are defined. The very concept of a line segment is a perfect example. A line is difficult to visualize because it goes on forever in both directions. It has no weight, it has no thickness, it has nothing except math. And to make it easier to express, we clip one off and we end up with a ray, and then clip the other end off somewhere, and we end up with a line segment, a line with 2 vertexes on it. And now it's finite and we can work with it. Nature doesn't care about details like this. All it cares about is maintaining the structure. So, the rules of holy geometry have places where they fudge. Gravity stops behaving properly in certain conditions. Light bends. And there are a lot of places where we have arbitrarily imposed our structure on this holy geometry. For example, the three-color system. The idea that red, yellow, and blue mix together to make all the colors of the rainbow, the primary and secondary colors, that's a man invention. Nature doesn't divide like that. The colors wheel past our vision endlessly in both directions. There are many colors we can't see. They can't be made with red and blue. Give me a break. You can even choose different colors. If you mix together cyan, magenta, and yellow, you can reach every color too. It's just evenly spaced colors. That's what you need. Then there's the musical scale. C, D, E, F, G, A, B, and then sharps and flats? No. Audio divides up into as many different notes as you want to create. It is possible to make a 29-key piano. Pianos fall out of tune and notes sound not quite right. It's simply playing something in an unexpected timbre. It doesn't mean the note's not there. It just means the piano's not capable of playing it. In this way, we introduce math to make the universe easier to understand. But the universe requires no such filter for itself. It has no use for something as rigid and simple as mathematics. The universe is supported by the holy geometry, the entity that is so complex and so detailed that only a god could have created it. Only a god could have maintained it. The holy geometry is one of the most powerful pieces of evidence that a supreme being exists, in my opinion. Because something as detailed, complex, and interconnected and interwoven as reality had to have been handcrafted. The more you study the holy geometry, the more you study physics and the nature of the world, the more you come to realize how everything has been very carefully set up to balance on the edge of the needle, so that the world that we live in only just barely exists. It's incredible the balancing act that went into it. From atmospheric pressure to the deflection of radiation to the transference of heat through a conduction, specific gravity, tidal motion, everything from the biggest creature to the smallest microorganism. So get this, here's something fun you can learn about color. You know how music runs in octaves, right? C, D, E, F, G, A, B, C, D, E. It keeps going. The human ears can hear a number of octaves of sound. How many octaves can a human hear? Let's ask Google. The average person can hear 10 octaves, from 20 hertz to 20,000 hertz. Hertz being vibration. 20 hertz is an extremely low rumble, and 20 kilohertz is a super high tinny wink. However, sound continues on past this. Vibrations can occur below 20 hertz and above 20 kilohertz, and we simply don't hear it. Color runs in octaves too. Our eyes can see about 1 octave of color. We can't see above it, no infrared. We can't see below it, no ultraviolet. But because light and color form the same wraparound pattern that everything else does, we get the broad strokes of what's going on from the world. We miss the details. We hear C. We only hear one C. We can't see the fact that there's very high Cs and very low Cs all being played together. We've only got the one C. Now, audibly, it's different. We are able to detect a very wide range of audible signals. 10 octaves is pretty good hearing. But we can only see one octave of color, only one band. So there are many types of color that are beyond our sight and not other animals' sight. They see the world differently than we do because they can see the colors we can't. All the microfluorescence and the extremely low tones. Amazing to think about. And you can sometimes just barely see them. You've ever seen the fuzzy color from a black light? You know what I'm talking about. Color that causes your eyes to glitch out because it's not quite visible. Your eyes are straining to understand the data coming in, but it's only just on the border of visible. The fact that we humans are designed to pick up one octave of a color, despite there being many octaves of color, we can pick up 10 octaves of sound. And that sound forms such beautiful and complex structures is only part of it. Did you know that your mind operates on specific sound waves? Brain waves occur at specific notes, meaning that playing certain notes literally aligns them to the patterns inside your head. Isn't that weird? Well, that's the holy geometry for you. There are rules in place for everything. And all the beings in the universe follow their own set. And we humans have been very carefully designed to survive on this planet, able to endure the specific radiations because the diffused light from the atmosphere blocks a great deal of the radiation, and the specific gravity holds an atmospheric blanket in place without crushing us to death. And the temperate zones cause intermittent change to the weather patterns, causing it to get warmer and colder, and for precipitation to fall and clouds to form and fog to move. And the tides cause water to shift, meaning that some areas are covered in water and then receive relief. Other areas are constantly covered in water. The variable conditions all over the planet give rise to incredible versatility and amazing variety in the beings that are present on this planet, in the plant life and the animal life. And all of this amazing detail sprang up thanks to the exacting conditions. You go visit other planets, you don't see it. None of this is on Mars. None of this is on Venus. Those places don't have our specific geometry. They were created via the same system, the same holy geometry, but only our planet has this amazing balance. It's so beautiful and so fragile. And you wonder where its limits are. And there are people who spend their whole lives studying the sciences, studying the nature of this incredible holy geometry. And they still don't have the answers. And the more answers they look for, the more questions they have. And that's part of the universe too. We are supposed to ask these questions. We are supposed to be curious about the world. The world has many benign secrets, many things that won't hurt you, but are very interesting, because humans become stronger through our curiosity. It is our desire to understand that gives rise to our ego, that helps create our sense of self. It is our desire to understand the world around us so that we can manipulate it and control it. It is all set up specifically for us to explore. All of it was created so that we would ask what the heck is going on and explore. And so we would create things like math and language to parse the world around us. And we would communicate with each other about what we've seen and create our own things in time. It is the biggest lie of the universe to say that science proves that God can't exist, when it's the other way around. The very presence of all of this detail is nearly concrete proof that someone designed all of this. Because the questions keep going. More than anything else, the questions keep going. At first, we believe the Earth is the center of the universe. And then we believe the sun is the center of the universe. And then we believe the Milky Way galaxy is the center of the universe. Then we think that somewhere else is the center of our universe. And then we realize there is not only one universe. Every discovery leads to new discoveries. There are questions that continue to emerge the more you explore a topic. The world is set up with this amazing recursive detail, a fractal system where the more you look and the closer you examine, the more there is to see. The world is cram-jammed with so much wonder that humans will forever be curious about what's going on around them, that they can latch on to almost anything and start learning and never stop until the day they die. And our hunger for knowledge, our desire to understand the world beyond us, leads us to create magnificent things. Our desire to understand and copy and comprehend the holy geometry, the structure of our universe, leads us to ask questions. And those questions don't always have easy answers. We think to ourselves, oh, dinosaurs, they contradict the Bible, right? Well, no. There were creatures called behemoth in the Bible. They could have been dinosaurs. Or perhaps dinosaurs simply came before men, and men never encountered those beasts. They existed, and then they left, and then man got their chance. It may have been part of the setup. We are meant to ask these questions. We're meant to see what can be done. People like, oh, global warming and pollution means there's no God. Well, that's a very rough perspective, because this system was very, very carefully designed to the point that we humans would influence it and possibly learn lessons from influencing it. What's more, the physics of reality are changing. I'm looking up a specific thing that happened. There was a time in history, I can find it. Once upon a time, there was a very common cleaning chemical that was made. I'm trying to find it now. Basically, up until a certain point, right. Ethylene diamine tartrate. That's its name. Ethylene diamine tartrate. So here's what happened. In the mid-20th century, EDT was produced in large quantities for use as a piezoelectric material, a cleaner for electronics. It was produced for about 4 years. Then, all at once, a monohydrate form of the crystal began to appear, which was not what they wanted. They were trying to create a diamine, right? Once the hydrate appeared, it was a contaminant. Even in factories located miles apart, the process began producing this useless monohydrate instead of the EDT crystal. The hydrate would grow instead of the desired cleaning crystal, making it impossible to produce the original pure material, the disappearing polymorph. Now, because of this thing that happened, all at once, a cleaning crystal that had been produced for 4 years was not producible on the planet. It just stopped, vanished. However, in the same way that rules can be found and the rules can be changed, the rules can change again. So, in the mid-20th century, they were producing this cleaning crystal called EDT. And then, all at once, it started growing useless crystals. Once it started growing useless crystals, it wouldn't stop. The geometry grew a new shape. And once this started at one place on the planet, in a matter of hours, it couldn't be done anywhere. The hydrate everywhere on the planet just started producing the useless version. However, in time, they found that by keeping the growing solutions above 40 degrees Celsius, this secondary crystal would dissolve and allow the proper crystal to grow again. So, after performing a specific chemical reaction for a while, new rules emerged on the planet, and it no longer was possible to produce the desired result. However, studying this, we discovered that by altering our approach, it was possible to continue making it. We simply had to follow the new rules. The spontaneous nucleation of this hydrate-rendered industrial crystal had to be done under strict high-temperature conditions. As long as it is hot enough, the chemical can be made. It's incredible, though. The idea that a substance that we thought we fully understood just started changing. It gets deeper than this, too. The very concept of quantum mechanics didn't work. It didn't work until all of a sudden, it did. All at once, quantum mechanics started working. Did we only just notice? Are we only just reaching the point where we can understand it? Or are the rules of holy geometry changing? It's probably a little of both. Pi hasn't changed. There has never been a situation like ethylene diamine tartrate again. EDT is the only situation in reality to this point where we had an established manufacturing method for a specific chemical that just stopped working. All at once across the entire planet, snap, can't make it anymore. And then after several years, we figured out, okay, and if you want to make it, now you have to raise the temperature. You can't make it cold anymore, it must be made hot. It was an amazing situation. But it serves as a demonstration that the rules to this planet are not a single absolute, but in constant flux, always changing. The idea of quantum entanglement serves as the next big question that we can get to. Science does not have fixed rules. Progress is often made by ignoring conventional rational standards. When it comes to judging whether a scientific theory is any good, we must be pragmatic. We must ask ourselves, what do the results say? Because sometimes the ideas that sound the most outlandish can be the closest to correct. And indeed, the math is made to model after reality, not the other way around. So while the idea of quantum mechanics might seem ridiculous, it leads to highly accurate predictions, many technological applications, and Richard Feynman once famously said, "I think I can safely say that nobody understands quantum mechanics. It has weird and counterintuitive implications, and it's always mysterious." But the thing is, quantum mechanics represents the next question. It's simply something that we don't understand well yet. Give it time. Give us room to understand and explore it, and we will find the math behind quantum mechanics. We will create a system of estimation, and it will be functional. And then once we have our math, we will start looking for errors in the math. And before long, we will have a much better explanation of what quantum mechanics are, really. Not some guess based on changing the past to change the future, to twist it around to cause entanglement, but a true understanding of what's happening. That could be it, or maybe not. Maybe the idea of the changing the past to change the future to get around it, maybe that's all nonsense. Maybe entanglement doesn't work like that, or maybe it does. All we can say is that this is how it is. And as long as you accept this is how it is, you can make some very tight guesses about how reality is going to react to things. Because the math checks out. You take the math and you're like, here's what the result will be. You're like, why is the result going to be that? I don't know. Doesn't make sense, does it? Why does it do this? We don't know. It should only have one state. For some reason, it alternates between them. What in the world is this? We don't know. But we do know the results. We have observation, not understanding. And as long as we accept that as the truth, we can catalog what's going on. We can estimate what's going on. Estimation before understanding is the nature of mathematics. It is the step before God, not God itself. Math is our attempt to reach the greatness of the heavens, and it will always fall one step short. Because we're only human after all. Don't put the blame, no. I mean to say, we will never be perfect. So the math that we wield will never be perfect. It cannot be the same as the holy geometry. But every day we will grow it another step, trying to reach that level of amazing completion. I think we have reached the point in the broadcast where I've said what should be said, talked about the nature of mathematics. It's been an hour I've been rambling about this topic. I'm surprised anyone is still here. Good gravy. Quantum mechanics only represents the most recent horizon. There will be many more. Probably many, many more. My guess is new topics will stretch From the dawn of humanity first discovering fire, the very last person to understand the answer to the big riddle. The very last person to say, oh, I get it. We were all just fragments of the same being. We were all just tiny parts of the same whole. And as that one last piece of the jigsaw puzzle clicks back into place, and humanity is unified again, all the answers will be known. And the project, whatever it is, will be over. It's a long way off. Many, many obstacles in the way. And it all starts by solving math problems. Math is our tool, but it's nice to know that it has God's stamp of approval. More or less the same way that a macaroni picture would have a mother's stamp of approval. Good job, kiddo. You did it. Hey, I'm not saying it's perfect, but it's definitely yours. And that means I treasure it. All right, thank you for listening. I'm going to hang it up for today. I will see you next time. Signing off.